Hi, my name is Rony Efraim from NVIDIA. Today we're going to talk about DPU and OVN enabled zero trust multi-tenant cloud on steroid. So first I want to apologize on my voice. Don't know what happened to it. So let's have some nostalgia. Our OVS history. We started the OVS hardware offload a long time ago at Mellanox. Our first showing of it was at OVS conference at 2016. OVS hardware offload code is upstream from OVS 2.8. Now at NVIDIA that acquired Mellanox, we continue improving hardware capabilities like GENEVE, connection tracking, NAT, meters, DPDK, and fully support Kubernetes networking offloads. Today, a lot of the SDN in the hypervisor is done by software. So it's not only software-defined network, it's actually a software that's running inside the cores of the hypervisor. For example, running an OVS inside the hypervisor with a limited performance and consume CPUs. With the Connectix family as a smart NIC, we offload the data path of the OVS into the hardware. And we're getting a hardware acceleration. In that way, we can achieve 100 gig without consuming any CPU from the hypervisor. With a DPU like a Bluefield 2, we offload the entire OVS and OVN into the smart NIC. In that way, we get a full offload also from performance of all the, not only for the data path, also for all other things like connection tracking and OVN controller itself. In that way, we get a zero trust from the host, a total isolation between the hypervisor or a host into the DPU. Of course, we can also do it for a bare metal, and then we can run the OVS and OVN controller inside the DPU and create the same functionality as doing today for virtual machines, also to a bare metal host. So we always talk about Bluefield 2 as a DPU. So yes, it's the world's most advanced DPU. But let's look inside and understand what it is. So there is tile architecture running 8 ARM cores, A72 CPUs, which running in up to 2.7 gigahertz. We have up to 32 gigabyte of DDR4 DRAM. But I think, as a software developer, the actual bottom line, this is running Linux. So it's a fully distributed Linux OS that can run OVS, OVN controller, and all the other things, your own program that you want to bring. Of course, it's also including the best NIC in the market, which is the Connectix 6DX, that have 2 ports of up to 100 gig or either a single port of 200 gig. Of course, we have all the OVS acceleration, IPsec, TLS, connection tracking that's accelerated inside the Connectix. Besides that, we do have other accelerators like regular expression agent, PKA, and SHA-2. To complete it, we also do have a single 1 gig port to do out-of-band management, and a fully integrated PCI switch. As I mentioned in the first slide, today we have an OVN Kubernetes CNI offload, which fully OVN offload and acceleration as a primary network CNI. Network policy accelerate also included. The secure control plane running on the DPU ARM processor. Accelerated networking data plane leveraging the SRV DPU switch dev mode. Untrusted worker node. Create a zero trust from the host. Direct host DPU communication is not allowed. As you can see on the drawing here, there is a bare metal host that's actually running CNI. This CNI is only talking to the Kubernetes master and actually giving only the virtual function ID to this Kubernetes master. The Kubernetes master is talking to the OVN controller through the OVN northbound. The DPU that don't have any communication with the bare metal host is only communicating with the OVN controller to the OVN DB that is running on the OVN central and getting all the information in order to configure the OVS that is running inside. In that way, as mentioned before, there is a zero trust between the DPU and the bare metal. All the communication between them are using the OVN central. So why we always talk about hardware acceleration? So I think the main reason is the performance. So you're probably familiar with the numbers of OVS or even OVS DPDK that is running inside your hosts. So the numbers there are roughly 1 million packets per second. In ConnectX 60X and in Bluefield 2, we can reach up to 75 million packets per second, which is 75 times better. Beside that, of course, of the better performance, we're also getting it for free. So we don't need to consume any CPU in order to forward those traffic. Another interesting use case is, of course, when you have connection tracking and you have like 500,000 connections, of course, each of them sending traffic all the time, and there is a lot of cache miss to process those packets. In that environment, an OVS DPDK is dropping down to 500,000 packets per second. And in that case, a Bluefield 2 can reach about 25 million packets per second, which is a 50 times better than what you can do in the software. And of course, remember, we don't consume any CPU to do that. So I think now you can understand why it's needed to use the acceleration. So you will find also in the OVS OVN conference other talk of my colleague, but let's start with the questions now. Thank you.
Let me welcome Rony into the set of presenters. Rony, if you look, you should see a banner on your screen inviting you to join the presenters. If you click yes on that, then we can interact. We only have a limited amount of time because that used up most of our 10-minute slots. But if you click yes, then we can have a quick discussion. Welcome, Rony. And if you want to turn on your camera and your audio, let's see if there's anything you'd like to add to your talk. I don't see any questions posted yet.
So I don't have anything particular to add, but we have a very good partners, and I see a lot of talk about hardware offload. And as I mentioned, I remember was why we need to do hardware offload.
Okay.
Now,
well,
top.
Unfortunately, your audio is breaking up for me and probably for other people. Thank you very much again for the talk and for your work.